Good morning, 8th graders. Today we're going to start with linear equations. I know we didn't really have any closure to chapter 11 necessarily, but I wanted you to practice manipulating those equations because in this unit we are going to have to change equations and move things around. So what we did in chapter 11 was really helpful and important, and so, but I don't feel that you guys need a quiz or a test on it, okay? Just get the partner worksheet done and those other, the quizzes that I put out there and that kind of thing. So we are going to do day one, and day one talks about slope, okay? And I think that you guys, we hit this a little bit as 7th graders, but this packet is going to do a really nice job going over things. So the steepness of a line is called slope. I can't write this morning. So the slope tells us how steep something is, and I think of a hill, I think of stairs, I think of a roof. Those are all things that I think about when I think about slope. So here it says circle the line with the biggest slope. Well, the biggest slope is going to be the steepest line, okay? The letter we use for slope is a lowercase m. I get asked all the time, why do we use M for something that starts with an S? And the reason is because it comes from the French word monter, which means to climb or to rise, which is just a little fun fact, okay? So when given the graph of a line, we need to know a simple definition for slope. And that is that we take the rise over the run, okay? The slope is the ratio of a line's vertical change, which is going up and down, change to its horizontal change, which is that flat. So that's what we mean by rise over run. Okay, it's a ratio. So how do we find the slope of a line when we're given a graph? Well, we can mark some points on the line, okay? And these points, this is where it gets a little bit confusing. These points have to be where it intersects perfectly on the graph. So I'm gonna mark a couple for us here. Like right here, and here, and here, and here. And the reason I selected these points, if you can see them, is because they cross that intersection perfectly. If you look at this one, it doesn't cross at that intersection of the coordinate grids there. So usually I start from the left and I find the rise or fall. Remember, fall is going to be negative. So up is positive, down is negative, and then the run, when I do this, I always move to the right, and the right is going to be positive. Now, we kind of set these rules so that we do it the same way every time, and you're less likely to make mistakes there. So I am going to go from one point to another. Now, it doesn't matter which 2 points I pick on my graph. I'm just going to start here. So if I go up 1 unit and I go over 2 units, up 1, over 2, up 1, over 2, it works every single time. So my slope is the rise, which is 1, over the run, which is 2. Okay? So later on, we will be using the slope formula, but today, or right now, we're just going to be using a graph. Now it says we will often get fractions that need to be reduced. Okay, that's important, that you're never going to write them as a mixed number, but you are going to reduce things. The images below show 4 attempts at finding the slope of a line above. Can they all be correct? Well, let's look. The first one is kind of like what we just did, 1/2. But what if I had picked this point in the point that's on the axis? Well, I'd get 2 over 4. What does 2 over 4 reduce to? 1/2. Well, what if I had picked 2 points that were even further apart? What does 3 over 6 reduce to? 1/2. And what if I picked the 2 points that were the furthest apart? What does 4 over 8 reduce to? 1/2. So if you notice, the steepness of the line didn't change at all. Our slope didn't change. So you have to remember that sometimes fractions are going to reduce to be the same thing. So when I told you before it doesn't matter which 2 points you pick, it really doesn't. Okay, the next page. So we are going to practice here. So again, first you need to find a couple of points. So I'm looking, it looks like here. If I do one more. Okay, so remember up or down first. So I need to go down 1, 2, 3 units. 1, 2, 3. And our down was a negative. And then I'm going to go to the right. 1, 2, 3, 4 units. Can you reduce 3/4? Nope. Okay, our next one looks like right here, right here. So I'm going to go up on this one. 1, 2, 3, 4 units. So up 4 is positive 4, and to the right 1 is a positive 1. What does 4 over 1 reduce to? Just 4. Okay, my next one looks like I've got a point there and a point here. So I'm going to go up 2, positive 2, and to the right 1, 2, 3. Can 2/3 be reduced? No. Okay. And the next one, it looks like they intersect perfectly on every one. So I would go down 1, right 1. Negative 1 over 1 just reduces to negative 1. The next one, I would go down 2, so negative 2 over 1, and that reduces to just negative 2. The last one here, let's find a couple points. So I'm going to go up 1 over 1, 2, 3. So I get 1/3, and that's a positive. Okay. So just pause to make sure you're caught up there. And then we just want to take and observe something here. As we travel to the right, so if you go from left to right, kind of like you were reading, the graph goes up on these types of graphs. This is going to create a positive slope. As we travel left to right and the graph goes down, the type of slope is going to be negative. And this is going to match. If you look up here, going down from left to right, it was negative. Going up from left to right, it was positive. Okay, so if you were standing on a flat surface, what type of slope of this? There is no slope. The slope is 0. If you had skis on, you wouldn't be moving. And then the last one is if it's vertical. You can kind of see the blue line that goes straight up and down. This graph is so steep we can't even call it a slope. It is undefined. One big thing is you have to remember that 0 and undefined are not the same thing. Okay, the next part, we are going to use a slope formula. So it says sometimes we are not given a graph, but instead we are given 2 points on the line. When this is the case, we must implement another definition of slope. Okay. the slope of a line containing 2 points, x1, y1, x2, y2, can be found using the formula below. So the formula reads y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now, these are not exponents. They are simply there to show us the difference between the first point and the second point. So we're going to do an example. It says find the slope of the line containing the points. So the first thing I do when I'm given 2 points and I know I need to use them in a formula is I'm going to put x1, y1, x2, y2. This is the first point, this is the second point. And then I'm going to plug them into this formula right here. So my y2 is 3 minus my y1 is 1. My x2 is 2. My x1 is negative 4. Okay, then I actually have to do the math. What is 3 minus 1? You get 2. 2 minus a negative 4, what happens? You can use a calculator if you need to, but this turns to adding the opposite, which gives us 6. What's 2 over 6? 1/3. That's how you use the slope formula. This is a really little step that a lot of people forget, or they just don't do it because they're kind of being lazy. But it's huge. It really helps you keep those organized and make sure that you put them in. And then the other thing to remember is that in the formula it is subtraction. So what's kind of nice is these images right here just show you what you did. So when you took 3 minus 1, what you were doing is you were taking and finding the rise. So this was 3 minus 1 gave you 2 units. Okay, and then we found the run, so this was the rise. And we found the run, we found the difference between the y's. So this point was a negative 4, or this was a 2, and this was a negative 4. When you subtract the 2, you get the run, which was 1, 2, 3, 4, 5, 6. And then you put those together to get the slope. Okay, so this is how we do it without having a graph to look at. Okay. So before we start finding the slopes, we're just going to practice reducing and dealing with some weird slopes. I get the question a lot of times, well, what if the negative is on the top or the bottom? It does not matter. If there's a negative anywhere, the whole thing is going to be negative. If both the top and the bottom are negative, like these ones, what happens? A negative divided by a negative is going to be positive. So we're going to start right here. Can 3/9 be reduced? It can. So 3/9 reduces to 1/3. Negative divided by a positive is still a negative. 4/10, they can both be divided by a 2. So this gives us 2/5. 4 over 1 can we just reduce to 4. Negative 7 over 1 can reduce to a negative 7. You can just ditch the 1. 2/3 can be reduced, but negative over a negative gives us a positive 2/3. 1/8 can't be reduced, but negative over a negative gives us 1/8. 4 over negative 7, there's that negative in the bottom. Just remember that the entire thing is negative. It doesn't matter if it goes with the top or the bottom. And this is going to be 4/7. Same thing with the 1/8. Now 0 divided by 12. If you have nothing and you split it 12 ways, how much does each person get? They don't get anything. If you have nothing and you divide it by -2, what do you get? Nothing. But if you have 12 and you try to divide by 0, if you split it up 0 times, are you really dividing? No. So this is called undefined. You will also see this expressed as a 0 with a line through it. So you guys can use it. I know you always like shortcuts. Okay, so the last little part of the lesson. we're going to use a slope using the slope formula for these 6 points. So remember, x1, y1, x2, y2, and then plug it in. So 2 minus 1, so 2 minus a negative 1 over 6 minus 4. And to be honest, it doesn't really matter which one you make your 1s or your 2s, as long as you keep them together. So 2 minus a negative, it actually turns into adding. 6 minus 4 is 2. And you keep your answer as an improper fraction. So reduce it, but don't change it to a mixed number. x1, y1, x2, y2. Plug them into my formula. 3 minus a negative 2 over 4 minus 3. Again, this turns to adding. I get 5 over 1. You can just write that as 5. x1, y1, x2, y2. 12 minus 4 over negative 3 minus 0. 12 minus 4 is 8. Negative 3 minus 0 is negative 3. You can't reduce 8/3. I do put that negative just out in front like this. Okay. x1, y1, x2, y2. 1 minus 7 over negative 3 minus negative 1. 1 minus 7 gives us a negative 6. This negative 3 plus 1 turns into a negative 2. Negative divided by negative is a positive. 6 divided by 2 is 3. And if I'm going too fast at all, you can just pause the video. x1, y1, x2, y2. 7 minus 7 over negative 11 minus 3. 7 minus 7 gives you 0. Negative 11 plus a negative gives you a negative 14. 0 divided by negative 14 is 0. And the last one, we have x1, y1, x2, y2, 10 minus 4 over negative 5 minus negative 5. 10 minus 4 is 6. Negative 5. You actually end up adding 5, which is 0, and this is going to be undefined. And I'm going to take that back. I want you to use this instead of that 0 with a line through it, just because sometimes that 0 with a line through it is used as no solution, and I don't want you to get the two mixed up. So it's undefined. That's definitely what we're going to call that. Okay, thank you guys for listening. Now if you go to the next page, you can see the slope assignment right here. Okay, so it's just one page. The linear equations is what we're going to do on Wednesday. So you just work on this slope, and then I have a couple IXLs that I'll put on there for you, and that's it. I hope you have a great Monday.